So we've been talking about biology and physiology these past couple days in class. I haven't posted yesterday's video yet, so that'll be up probably sometime this evening. What we've been talking about so far, if you've been following along, of course, is the brain. We've worked our way through basically what's the hindbrain. We're talking about that part of our brain that's basically autonomic. That part of our brain that's basically automatic. So the hindbrain, of course, being basically the brainstem, including the cerebellum, which is this part down here, and then coming up mostly up through here. Then we talk about in yesterday's class how the thalamus is pretty central in terms of it being in the limbic system, it being in the midbrain, that is to say, being in the part of our brain that mostly deals with emotion, which we talked about yesterday, how that part of our brain is dealing with emotion. But the thalamus is actually having really more functionality that's connected to the brainstem. And most of what's going on down here in terms of those structures, if you remember, is routing information. And the thalamus is also just doing that routing of information, routing of sensory information in particular. And so we've talked about those two areas. So the autonomic area, heartbeat, routing information, reflexes, all that stuff in the hindbrain. We talked about yesterday the midbrain, which again is mostly emotional content. It's going to be fight or flight, it's going to be hunger, this is going to be horny, this is going to be joyful, this is going to be afraid. All of those things are mostly happening right there in the limbic system, which is what we actually call the midbrain. And so today, we're going to start talking a little bit more. We did get into some of this yesterday. We're going to start talking a little bit more about the forebrain, or what we call the cerebral cortex. The cerebral cortex is this area, this kind of wrinkly area that you probably most associate with the brain. Now, this image here is the brain facing forward and then sliced directly in half this way. So you can see you've got these two lobes over here, and then all of this stuff right here is basically what we were seeing in that image down there, that kind of central piece with the thalamus and all of that. So this is, again, the cerebral cortex. What do you notice, and it's kind of true of life, what do you notice about this wrinkly area here? What's something that maybe you can observe by just looking at it? It's not a trick question.
It's larger.
Okay, it's larger than
The previous person looked at.
Okay, so it's the largest piece of our brain, very good. And this is in fact the part of our brain that is the largest in terms of being human, right? This is the part of our brain that makes us smart in the way that we think of when we say humans are smart, or dolphins are smart, or chimpanzees are smart. They all have a pretty sizable cerebral cortex. And in the case of a dolphin, for instance, right, we don't really even understand exactly how their brain, how their intelligence works, but they seem to have a cortex as large as ours, though they seem, by our measure, to be less intelligent, but what do we know? And then, of course, chimpanzees have a relatively large one, but ours is certainly larger than theirs. So yeah, this is the part of our brain that makes us smart. What else do you notice? Yes, ma'am.
It surrounds everything else.
Okay, so it's surrounding everything else. It's on the outside. This is interesting a little bit because, well, while it's the part of our brain that makes us smart, it's also the least important part, right? It's probably more important that we can get our heart to beat. It's probably more important that We have a fight or flight response if something is really dangerous to us, than it is that we can work out a math problem or plan our vacation next month. Right, that's what that part of the brain is doing. So yeah, it's more vulnerable, you might say, because it's on the outside, but it's also less critical. You'll still live if you get a piece of that taken out. If I take out some of your spinal cord, you're either going to be dead or paralyzed or in a coma. What else? There's something there that is illustrated purposefully. They didn't have to do this. Yes, ma'am?
The blank space?
You're talking about these blank spaces here?
Like it's a bunch of white and it's like outlined.
You mean this?
Yeah.
Awesome. Not blank space. Very good, though. This is what we call white matter, as opposed to this other color, which looks pinkish here, but we call it gray matter, and if you see it for real, actually let me show it to you for real. It's gray, so we call it gray matter. That one. If you're interested in brain science, there's this really great little YouTube series. You can see it here in my playlist. They've got two of them. They may have a third. They were releasing them kind of year by year, or this one maybe the same year. But they are basically dissections of the brain, which is great. This one's great. And so you see her kind of go through the brain here and really just cut into it, and she starts labeling all the stuff that we're talking about in class and some of the stuff that you might talk about in other classes. But here you can see in this image, right, and it's tougher to see, but you can see it, that you've got these light parts, and then you've got these darker parts of the brain. You've got these light parts and you've got these darker parts of the brain. Those dark parts, again, are called gray matter. And the difference between white matter and gray matter is basically that the white matter, when we looked at those nerves at the beginning of the class, right, so we've got this nerve here. This is the white matter, and this is the gray matter. What's this mean? Well, it means that the white matter is actually just the connections, right? These are just the pathways. Whereas the gray matter tends to be the landing places. The gray matter tends to be where the information is going, whereas the white matter is just a route, it's just a road. It's just a trail to the other parts of the gray matter. And this is, one, demonstrating how interconnected the brain is. Almost half of that matter, if not more, is white, which is suggesting how interconnected the brain is. And the other thing to know is that in these gray places is where you can really think of the processing happening, where the work of the brain is being done. Again, the white matter is moving, and the gray matter is processing. The more white matter a person has, the more interconnected their brain is. What's interesting about this is that women have more white matter, and men have more gray matter. It is to say, women have more connections, and men have more landing places. This looks like maybe. This looks like, and again, all brains are likely to be different. So for a more feminine brain, you tend to have something like this. Let me simplify this. Please understand that the connections go in all directions, but I think it'll be easier to understand if I don't show it to you that way. masculine brain, you've got this. Any thoughts? We're just speculating together. I want to talk to you. You look concerned. Any thoughts about how this might show up as gendered differences? Any thoughts about how this might play out in terms of behavior or thought patterns? Yes, sir.
So, if I'm understanding all of this correctly, the more of the transmitters, the white matter, allows you to think more over time because it takes longer for information to process. So maybe it shows that women think on something longer, but then the men will think on it shorter and act on it sooner.
Okay, yes, that's a great theory. Especially what you've said here for the guys. You've left out a benefit of this. Remember that this is not linear. This isn't really in a line, right? Really, this looks like, how I drew it before. All of these things are, right, and guys will have more like this, right? Difference. Thank you. Yes, ma'am.
It seems like, I don't know, this might be like a biased opinion, but it seems like women have more solutions. If they're thinking about a problem, it seems like they'd have more solutions, whereas a guy would be like, well, I have this, this, and this, and then they're like, okay, we'll look at all of these, and then they have more ways to connect what they're trying to make their point.
Good. So I like what you said about connection, and I like what you said about perhaps more solutions, right? That they may be connecting to a lot more things. Let me give you another piece of this puzzle. Can you remember this? All right, you got it. Here, let me do this. What's interesting is if you look at the brain of somebody who's got an autism spectrum disorder, right? What we may say about folks with autism is that they actually have, just in terms of neurology, a hyper-masculine brain. Say that folks with autism have a hyper-masculine brain. What they mean isn't necessarily that, that autistic folks are, I don't know what masculine means. They have big beards and drive big trucks and, hair on their back. No, that's not what they mean. What they mean is that their brain looks exceptionally male, right? Even more processing places and even fewer connections. I'm illustrating this to maybe give you a hint about this difference. A couple more thoughts. What else here? She's on the right track. Yes, ma'am.
By saying more connections, are you trying to say that there's more thought that goes into it, or are you just saying that there's more things that come up, kind of like a look, a shiny thing over here, and then that's something completely different, whereas that's not necessarily something important that contributes to the thought, but it's something else.
Sure. So you're kind of describing an attention deficit type thing, and that's not what that looks like, right? That's a great thought, right? You might think, okay, well, if all these connections, then they're gonna go off in all these directions, something like that. But it doesn't look like I can't control myself from, right, what ADHD looks like. What do we know about autistic folks? What do people say about that?
They tend to be really smart in a certain thing.
Right?
So they may be really good at math and may be able to think like that on it, or science, or
Right. But that intelligence isn't necessarily shared with a lot of different things, right? It tends to be really specialized, right? And what you can know about this kind of, these routes, right, and this should illustrate that this is longer, of course, than this route, right? For this to get to here is longer than for this to get to here, is that what this probably looks like is it takes more effort to connect this dot, right? You know a lot about trains, but I ask you about tractors, which are kind of similar. I mean, they're connected. And you don't know anything about tractors. Tractors are stupid, right? So here you can see that, right, this thing doesn't necessarily as easily connect to this thing. And maybe even if they do know about tractors, it's so far away. Why are you bringing up tractors? Talking about trains. Any boyfriend ever said this to a girlfriend? Why are you bringing up? Is this a thing? So what do you think? What am I trying to tell you? Yeah.
I think we're able to switch topics very quickly and fast, and we can notice the interactions between them.
Right, so it's not this sort of attention deficit, you're all over the place. You can hold all this, right? We're talking about this thing, did you remember this? And oh yeah, Becky's gonna be there. You know how she is. You better make sure you remember. I'm just trying to plan the vacation. What car are we taking, right? And you tend to see that a more feminine brain is connecting more dots, right? They tend to be considering a bigger picture because just the way their brain is structured, they're able to, right? If you're using, and this is not how the brain really works, but if you're using this much space to concentrate on a topic, right? We'll do it this way. And they're using that same amount of space, right? They've thought about that a lot, but they didn't think about all of this, or this thing. This also suggests, and a bigger piece here, is to think about, this is a stereotype, but let's explore it, that women tend to be more emotional, or at least have a better sense of their emotions. This is because, well, the brain is separated into different places, and there's a point or a place in the brain where your emotions get processed. And if the brain is just better connected overall, well, guess what? You're gonna have a better connection to those emotions, right? And so the woman's brain, or the feminine brain, I should say, there are some brains, men's brains who look more like this, and some women's brains who look more like this, right? So the more feminine brain is gonna have that better interconnection. This is another stereotype, but women tend to also express emotions more. Let's talk about sadness. Some women might get upset about smaller things, right? And be comfortable in that. It's something sort of amazing about a woman, women that are this way, is they can tend to be really comfortable in their emotions, and they might reach into them, experience them more. Right? A woman sees a movie, cries a little bit. You ever seen a man cry? Like really cry? It's not a weepy. Right? When men are crying, they're crying. And so, and again, this is just my own speculation, but again, I sense, right, when they get to that emotional place, it's full, right? It's a lot more to process. It's a lot more to experience, and because they don't necessarily make this jump as often, right? It may also, just psychologically, be more pent up. So I think this kind of stuff is fascinating. I really am just speculating with you about the effects of this. We really don't know. But for me, it makes sense. We do know that this is true. This is true. So I'm just speculating with you about what that might mean, what that might look like in terms of behavior and in terms of psychology. Questions about that? Okay. So if you're interested in this is I do really like this series, and if you're interested to see kind of what these things look like, you know, she really does kind of take you all the way through the brain and let you know what's going on. All right, so let's talk just a little bit about the cerebral cortex overall. thing before. One more thing before we switch off of this. This connection piece. You see this? See those like two eyes right there, right? And the sort of eyebrow over top. You guys see this? That's called your corpus callosum. It's one of the main and one of the only pathways between the left and the right hemisphere. Now you see that the two hemispheres are touching down here, but this is the limbic system and it's kind of doing its own stuff. It's not really part of the cerebral cortex. The cerebral cortex, again, that top more wrinkly part, that outside piece. And that little sliver of white matter there is really the only connection between those two things. And what this also means about the difference between a more masculine and feminine brain is that women have better connectivity between or across hemispheres because they just have more white matter. That includes this connective tissue between the hemispheres. In yesterday's class, and we probably won't get to it today, but in yesterday's class we talked a little bit about the difference between the left and the right hemisphere. Basically, the difference being that the right hemisphere, controlling your left hand, that the right hemisphere is better at something that we call parallel processing, and the left hemisphere, and the left hemisphere is better at something that we call serial processing. A serial process is one in which you have to take in or understand information, what we say bit by bit. It's how we read, right? You can't just open a book and know the text, right? You have to read it word by word in order to absorb that information. I do a little demonstration to start this conversation where I ask one student to tell me how many dots he or she sees. How many dots you see? 4. Okay, and then I ask another student. How many dots do you see, sir? It's taking me so long.
10.
Are you sure?
Yeah.
Took you a really long time. How many?
4.
How many?
10.
You're faster that time. Did you have to, or how did you know this was 4?
I kind of have to count them.
You counted them?
Yeah.
You had to count these? All right, well, we'll talk after that. Who didn't have to count those? Most people, right? And we talk about how this is a process that actually is called subitizing. Whereas for something, I didn't count these either. I think you might be right. 4, 7, 10. Right? We actually have to count these. We actually have to go one by one. Boop, 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 right? But here you can, most people, right, can look at that and go 4 dots. You just recognize it. And so this is a parallel process. You're able to just, boom, absorb it. I know what that is. This is a serial process. Again, how you read. The dog went to the store and found a cat. This makes sense? Serial versus parallel processing. Your left brain is better, your right brain is better at this parallel processing. Parallel. And your left brain is better at this, I keep doing it, this serial processing. This is the difference between, again, how we take in, for instance, text and how we take in an image. If I showed you an image really quickly and shut the book, you can tell me what it was. If I showed you a paragraph, you're clueless, right? Vice versa, if I showed you words on the screen, I just flashed one word in the middle of the screen and it was a sentence. And at the end of that, I said, what did the sentence say? You could probably tell me that. But if I showed you an image 1 pixel at a time, and I said, what was that? Can you put those images together in your head? You probably can't do that, right? you need to process images parallel. Whereas text, you tend to process that in a serial way. And we do different things, we do different types of processing for various other things, but broadly, if we're trying to get an impression, that's a parallel process.
Is that why logos and branding is so important?
Yeah, right?
Instant recognition.
Yeah, you just recognize what it looks like and you don't have to read, right? Imagine if, I don't know, even just Nike had a different font every time. Oh, that's Nike. But it's always in the same font, and it's got its little logo, instant recognition of what it is. You don't have to count them. Right? You don't have to read it over again. Yes, ma'am? Two dogs.
Like if somebody has like a photographic memory, would that be considered serial processing? Like if they can like look at a piece of paper and then like remember everything that it says?
Sure, there's a piece of, that's gonna happen in terms of absorbing the memory. We call that an iconic memory. And everybody has an iconic memory, it's just how long. Generally, it's like a second, right? If you could reproduce the image in a second, you could do it. You would have it in your head exactly as you saw it, but it fades really, really quickly. People that have that type of memory, basically they can hold that, right? They don't forget that image that they saw the way that we will almost immediately forget it, sort of word for word at least, right? You can sort of go, oh, it was a landscape and there's a duck there, right? He can get it generally, but exactly. There's also that for auditory memory, being able to remember exactly what you heard as you heard it. It's called echoic memory. We all have that as well. That lasts a little longer, right? And you may can think of a time maybe you've heard a song or you've heard somebody say something in a weird way. Yup, right? And you could do that immediately like I did it, right? For a while, you could repeat that just like I did it. Does that make sense? That type of echoic and then iconic memories. All right, what time is it? All right, so yeah, let's look at let's watch this.
Each doing half the work of your brain is two brains, two hemispheres, each doing half the work of being you. Half your vision goes to each and half the movement directed by you. Right controls left and left controls right. Your two brains coordinate through a wire of nerves, but this wire can be cut and was, for a time, used as an epilepsy treatment. After the cut, people seemed the same, though their brain was split in twain. Except some post-split patients described that while selecting their morning outfit with right hand, left might come along to disagree. Actually, left hand might quite often disagree, which these split brain patients found frustrating. What's happening? To investigate, remember, right brain sees and controls one half, while left brain controls and sees the other. But only left brain can speak. Hello. Because that's where the speech center is located. Right brain without this is mute. In normal brains, this doesn't matter because each half communicates across the wire with the other. But split brains can't, and thus you can show just the right brain a word, ask the person, what do you see, and you'll hear nothing. Because left speaking brain saw nothing. Meanwhile, right brain will use its hands to pick the object out of a pile hidden from left brain. This is deeply creepy. Ask why are you holding the object, and speaking left brain will make up a plausible sounding but totally wrong reason. I always wanted to learn how to solve one of these. Left brain isn't lying, it's just doing what brains do, creating a story that explains its past actions to its current self. A behavior which does rather cast doubt onto the notion of free will, but that's a story for another time. Creating reasons for why it does things is just something left brains do. It happens in normal, healthy humans all the time, and if you think about it closely, you know you've done this. Back to experiments. Give right brain an object, ask the person what's in your hand, and they won't be able to say, I'm not holding anything. And when asked to draw, a split brain can draw two separate objects simultaneously with each hand in a way unsplit brains find challenging. These experiments on split brain patients aren't deeply unsettling because they really point in the direction of a mute, separate intelligence, something living in the skull. You can even ask questions of a split brain and get disagreement on the answer. So if your brain is split, who is the you in this situation? From the outside, it's tempting to think of the part of the brain that's speaking as the person, but something is hearing and answering questions. And the right brain can't speak, it does understand faces, which left brain can't. If this is you, you don't know who your friends and family are in the crowd. This act of cutting exposes two minds in one head, and the talking mind doesn't know there's someone else in the house. The left brain can describe the situation it's in, but nonetheless will constantly be surprised by right brain's actions and explain them away. There's a question to be asked here. Why, after separation, does right brain not totally freak out, but instead plays along helpfully, answering questions and listening to left brain's dumb stories about what's happening? It's the best pony? I don't know. Speculation time, but one answer is the cutting doesn't make right brain a separate intelligence, consciousness, person, but rather it has always been. In normal people, perhaps right brain grows up as a companion without a choice, feeling at first somewhat equal partners, but then as speech develops that it can't participate in, that increasingly becomes the central point of life, it resigns to mutely coordinate with left brain. At this moment in your normal head, there are two of you watching this video. One having a mind equals blown moment, and the other mentally rolling its eye at the obviousness of it all. In split brains, right doesn't freak out because not a whole lot has really changed. You might not agree and may be arguing right now why it can't be possible, exactly as you would expect talking left brain to do. Speculation aside, split brain patients show at the very least that in the mind there is a separate something that can hear and understand and respond given the right circumstances. Your brain isn't entirely yours. Who is you? You is too.
What do you think of that? So again, you see here that the two brains have the two halves of the brain have some different functionality. I do talk about in class yesterday how these differences aren't as stark as you tend to hear in kind of popular media, right? Left brain people being like this and right brain people being like that. There is a hint of truth in that. Again, this part of the brain can do this type of processing. It's just better at this type of processing. It's just better at processing things all at once. So, you heard in that video there that they said it's the left brain that can speak, and this is true, and probably in tomorrow's class I'll start talking about how that occurs, but basically you should just understand that the left brain needs to speak because speaking, again, is a serial process, right? You need to be able to decode things word by word and put things into a serial process in order to explain them to other people, right? You gotta choose the right word, or else other folks won't understand what you're saying. So the left part of the brain is understanding and producing speech and understanding language. And basically, if you look at the brains, the front of the brain, and on the left part of the brain, it's about right here. Again, in tomorrow's video, you'll see me get into this a little more. What do you think's happening over here? There's a clue, I'll give you a clue, right? It is related to language. These things are similarly tasked, but only this part of the brain can do language properly. That is to say, make words. What do you think's happening over here?
Is that side of the brain listening?
Nope, both listening and speaking happening over here. Speech and production of speech and understanding language, yep.
Is it patterns? Like recognizing patterns?
Say some more. What kind of patterns?
Well, it could be like speech patterns, it could be accents, it could be, I don't know, maybe your brain just like, have we seen this before? Do we know about this? Like.
Okay, you're on the right track. It is patterns. But what types of patterns? What types of patterns? What types of patterns? What types of patterns? Yes, ma'am.
Well, I think what you're wanting to hear is like our patterns in our voice. Like
Yes.
it can pick up on like are we sounding mad? Are we sounding angry and mad or the same thing? Sad, whatever.
Sure.
But isn't there a thing that like, if you can see the first and last letter of a word put in order and the rest is scrambled, you can recognize that?
Sure. So to just understand, right, just in terms of language recognition, some of what you're doing, and I wouldn't even necessarily venture to say that it's happening on the other side of the brain. It is a parallel process, what you're describing. I talked yesterday about this idea, just briefly about this idea of sight words that you learn when you're learning how to read, right? This understanding that you can't sound this out, right? You cannot process this word serially and get how it sounds. And so you have to just recognize it, right? That's probably still happening in your left brain. It is a parallel process, but just remember both can do either, one's just better at the other. Good question. Well, what was the answer? What was the answer I wanted?
Oh, that it was picking up on like different notations of your voice, like
Right.
how you're answering the question.
Very good. So this part of our brain is dealing with language, but this is the part of our brain that deals with the sort of musical nature of language. This is the part that's going to deal with intonation and cadence, right? And how I choose to space out my words, how I choose to space out my syllables. It's also going to, again, deal with some of those musical qualities, right? If you're singing, you're definitely engaging this part of your brain in order to understand where the notes go and how they relate to each other. We call this process, right? We call this language, speech. We call this process engaged by this part of the right brain, we call it prosody. And this is those characteristics of language that again are, for lack of a better term, musical in nature. Again, pitch, intonation, cadence, rhythm, all of those things that if you didn't have, your speech would be very dry, right? You wouldn't be able to add any color to the way that you're speaking, such that you would get the words right, and you'd even get the meaning right. But it would just be very boring, right? Like a computer's voice. They have no processing. All right, that's it. On tomorrow and next class, we will keep talking about, I'll keep talking about the cerebral cortex. We'll talk about the motor hemisphere, how you make yourself move. We'll talk deeper into this understanding of the parts of the brain that deal with language, and maybe just some other fun facts about that wrinkly thing on the top of our heads. I'll see you guys in a couple weeks, and I'll see you in video tomorrow.